This is RD Sharma Solution, Class 12, Chapter 18. Maxima and Minima, we are taking exercises 18.5. Given the sum of the perimeters of a square and a circle, show that the sum of the areas is at least when or is least when one side of the square is equal to the diameter of the circle. So there are two shapes we are talking about here. One is the square, the other is the circle. If you take one side as x, every side will be x because it is a square. Square means all the sides have to be equal. So sum of the perimeters of a square, let us call it as k. Square perimeter is 4 into x, and the circumference of circle is, if you imagine or if you take x as the side of the square, r as the radius of the circle, it will be 2 pi r. From here we would like to find out x in terms of r. So when we take 4x, it will be k minus 2 pi r. When we have to divide it by 4, then x will be equal to k minus 2 pi r by 4. This is our first equation. Now the second thing comes is the areas. Areas of, again, square and the circle. The area of the square is side square, which is x square. The perimeters was 2 pi r for the circle, and the area is pi r square. When we take the sum of the areas, the area sum will be this x square plus pi r square, that is the area of the square plus the area of the circle. So let me write it here. I am taking x as k minus 2 pi r by 4. It should be taken in the next step, but I have done it here only. And pi r square was already there. As I told you, it is the area of the circle. And x square, we have taken k minus 2 pi r by 4 as the x. Now we are differentiating. Let us differentiate this equation. And I always tell you that differentiation is your responsibility, because differentiation we have already done whole chapter on that. Differentiation of this particular thing will be twice of k minus 2 pi r, and 4 4s are 16 because 4 is in the denominator. I'll just write 4 square. The differentiation of k minus 2 pi r is going to be k will be 0, 2 pi will be 1, and only negative r, I think negative 1 will come. 2 pi r will be the differentiation of pi r square. See, the area differentiation is circumference. Now we have this dA by dr, and this has to be equated to 0. Just need to rearrange, because as I said, k minus 2 pi r also has to be differentiated, and that is going to give you negative 1, because negative 2 pi actually, not negative 1, it's negative 2 pi. This is essential because we are going to equate, and this 2 pi is going to cancel, or pi can be cancelled out. So this k minus 2 pi r differentiation, k is 0, minus 2 pi r will give you minus 2 pi. You get a negative here, and we have a negative and a positive. So when we equate it to 0, one side you can write it as 2 into 2 pi into k minus 2 pi r. The other side it will be 2 pi r. Now you can just cancel these things out, and you can have a relationship of r with this k. Or you can say that there is a relationship which we want in order to tell that there can be certain critical points. This differentiation equal to 0 is all about finding out the critical point. But we have a relationship here. And when we have this relationship, this k is going to be, you can write it as k minus 2 pi r equals to 8r, because we are going to reuse this equation number 2. I'm again differentiating, that is the double differentiation I'm completing now. The double differentiation, I'm writing the final expression right now, because I am again reiterating, the differentiation is your responsibility, and I'm very confident that you'll be able to do it. Pi square by 2 plus 2 pi is positive. Positive, this cannot be negative at all. It is positive. That means you are going to get the minimum value. And the question is also saying that at least is least. Least means minimum. That is why when we have an expression which is greater than 0, that signifies that we are talking about minimum, that is the least. Okay. Now k minus 2 pi r equals to 8r we have already got in the second equation. X was k minus 2 pi r by 4, and this k minus 2 pi r can directly be written as 8r. That is, the expression of 2 can be replaced in the expression of 1, that is k minus 2 pi r can be replaced by 8r, and this x is equal to 8r by 4. So 4 2s are 8, 2r you are going to get. X is equal to 2r. And twice of radius is nothing but the diameter. Diameter is from end to end line or a chord which passes through the center point. So if you remember, x was equal to 2r. The side of the square is equal to the diameter of the circle in order to get the least area that we have already shown here. So the side of the square is equal to the the diameter of the circle. So whatever I explain, this is written here in English like language, and you have to do exactly like this. You can change the language, but the content remains the same. All these writing is very important, as I have been reiterating. Find the largest possible area of right angled triangle whose hypotenuse is 5 centimeter long. Now just take the right angle. This is a right angled triangle. In this right angled triangle, the right angle triangle means one angle has to be 90 degrees. Largest possible area, that means we are going to go for maximum. 5 centimeter, the distance is already given of, or the length of the hypotenuse is already given. Now you can take any value x or y, either way. You can take x as base, y as the height, or whichever way you want. But the thing is Pythagoras theorem that says you x square plus y square is equal to 5 square. So all this written material you have to write by yourself. X square plus y square equals to 5 square is our first logic. Y square you can take it as 25 minus x square. So you have y square equals to 25 minus x square under root. So when you have this under root, y equals to this one, plus minus I am not writing because the distance of the length cannot be negative. That's why I am not taking negative. Otherwise it will be coming as plus minus. I am purposefully ignoring the negative sign. Coming to the actual thing, which is the area. Area of the right angle triangle is simply half into base into altitude. If you have taken base as x or base as y, it's up to you. But it will remain as half into x into y. Now half into x is already there. The y has to be taken from here, 25 minus x square. Area is this one. Now we will differentiate it. When we differentiate this dA by dx, because there is only x as a variable on the right hand side. When we differentiate this, as I said, differentiation will take certain time, and I'm just trying to get your time less or take your less time. So I'm writing the final differentiation that will come. You can do it using the product rule, and this is the dA by dx. This is the differentiation. Now once you differentiate this, you have to place it as 0 in order to get the critical point that we have been doing in the previous exercises also. If you equate it to 0, the denominator is going to be 0, of course, because it is being multiplied cross. So you will get 25 equals to 2x square, that is x square equals to 25 by 2. X will be equal to plus minus under root 25 by 2, and that cannot be taken, negative cannot be taken. Under root 25 is 5 and 2 will be root 2. So you get x as 5 by root 2. This is x. How about y? Y is under root 25 minus x square. That is, you have to just place x square. X square is already there with us, which is 25 by 2. So y also comes as 25 by 2. 25 minus 25 by 2 is 25 by 2 only. When you take the under root of this will come exactly similar to the value of x, which is 5 by root 2. Y is 5 by root 2, x is 5 by root 2. These are the similar values. And there is one more thing which we need to check in order to complete this question, which is the largest possible area or the maximum. That can be done using the differentiation again. So I am doing the double differentiation here. And this double differentiation simply means 25 minus 2x square by twice of under root 25 minus x square, again differentiating this one. I am writing the final differentiation here, minus 75x plus 2x cube divided by 25 minus x square under root 25 minus x square. This is the whole double differentiation which you will get. And we need to check it when x is equal to 5 by under root 2. When x is equal to 5 by under root 2, this is going to get us less than 0. You can try it putting the value as 5 by root 2 and you will get a value which is less than 0. Less than 0 value indicates that we are talking about the maximum, which is the largest possible area in the question, in the context of this question. So that is how we got the value. We also indicated that it is going to be less than 0. Alright, and what are the values? Because x and y is not enough. We need to find out the area. Area is half into base into altitude. Base is already 5 by root 2 and the altitude is also 5 by root 2. Root 2 in the denominator will give you 2. 2 into 2 is 4. So in the denominator you will get 4. 5 5 is 25 is already there. So 25 by 4 cubic units. Square units, sorry. So it will be square units. So what did I tell? This is in front of you. The differentiation might take some time, but it's okay. I hope that you will be able to do it. So this is the English like solution which you have to follow. Next is two sides of a triangle have lengths A and B and the angle between them is theta. Two sides of a triangle have length A and B. So we have a triangle. You can make any triangle because there is no 90 degree, there is no equilateral triangle, there is no isosceles triangle. It's simply two sides A and B we have to take. And this A and B which we have taken, the angle between them is theta. What value of theta will maximize the area of the triangle? Area of the triangle is half into base into altitude in terms of an angle which is 90 degree. That is the right angled triangle. But for a normal triangle, when you have the two sides and the angle between them, it's simply half into base into altitude with an angle. What kind of angle? It's sine theta. Half into base into altitude. There is no base and altitude here. I'm just saying this two sides containing that angle, half into A into B, and the angle between them with the sine of it. Now I am differentiating it because A is taken as the area. I am differentiating it. Sine theta will be cos theta. Next step is to equate it to 0, that you already know. I am equating dA by d theta, that is the differentiation, as 0. When I equate it to 0, you will get A into B into cos theta divided by 2 as 0. A and B cannot be 0, 2 cannot be 0, cos theta has to be. So cos theta equal to 0, that means theta has to be pi by 2, because we are talking about a triangle and the angle of the triangle cannot go beyond that. Highest angle can be pi by 2. If it is an acute kind of angle, obtuse of course it will be higher. So we'll stick with this pi by 2 and I'm differentiating it again. Cos theta will be minus sine theta. And since this sine theta value is already known, and sine pi by 2, what is the value of sine pi by 2? Sine pi by 2 is 1 only. When you have sine pi by 2 as 1, you will get minus half into AB, that is negative AB by 2. When you get a negative value, that simply means that it is less than 0, which is showing that we are talking about the maximization of the area of the triangle. When we have the maximization, this has already been done. And the next thing is the actual finding of the area. What is the final area? Half into A into B, that is the side holding the angle between them. What is the angle? Pi by 2, we have already known that. Half into A into B into sine pi by 2, which is 1. Area is AB by 2, A into B by 2, which is the maximum area of the. So what did I tell you? This is all what I explained, and this is how you are going to write. Especially the English sentences are the main key for your success, because if you explain it, you'll get it. A square piece of tin of a side 18 cm is to be made into a box without top by cutting a square from each corner and folding up the flaps to form a box. What should be the side of this square to be cut off so that the volume of the box is maximum? Find the maximum volume as well. Now just imagine this question. There is a sheet, and the square sheet is having all the sides, because the square has this feature that all the sides has to be equal. Since all the sides are 18 and there are 4 corners, and those corners, all the corners will have square cut from it. This is square, this one square, this one square, and this one square. That means all these 4 square corners will be eliminated, will be cut, and then will form a box. And please remember, this box has no top, will have the base, but there will no top. So what do you get? These all portion will be eliminated, and finally a box will be formed, and that box will be of course a kind of a cube. Since we don't have the cover, that is the top, let us take one of the square and then try to formulate the side, because side will be less now. 18. What can you guess? What will be the side of the square when one x is eliminated? See, x is one side, x is another side. 18 is the whole length. We eliminated x and x from two sides, so it will be 18 minus x minus x minus x. So 18 minus 2x will be the length. What will be the breadth? Same logic, because all the sides are 18. Again, on the breadth side also, the x side and x side is being eliminated. So again, the length will be 18 minus 2x, and the breadth will also be 18 minus 2x. X from one side, and x means corner, and other x from the corner. So volume will be length into breadth into height, and that will be in cubic units. The length and breadth, of course, it is going to be 18 minus x, that is 18 minus 2x. In case of breadth also and length also. So we have known the length and breadth. Now we have to talk about the height. What will be the height? Height is x, because of course the portion cut is x, and that will be folded, and once you fold the side of x, the height of the shape being formed, x will be the height. Now the next thing comes is the differentiation of this volume, that is x into 18 minus 2x whole square. And I can tell you that you can differentiate it by yourself, because it is quite easier and we can just go ahead without wasting our time. I am differentiating it using the product rule. First differentiation of second plus second differentiation of the first. That is what is the key. This has to be equated to 0, and once we equate to 0, there are certain things that are going to come up, and the way you are going to solve can be different from your friend, because there are multiple ways to even simplify the equation being formed. What you are going to get here, rather than doing this, take 18 minus 2x terms on one side, take 18 minus 2x as common. Once you take 18 minus 2x common, you are left only with 18 minus 2x minus 4x, because 18 minus 2x we have already taken common. So you are going to get 18 minus 2x minus 4x, that is 18 minus 6x here. The best way, because this is all equated to 0. Remember, 18 minus 2x divided by say 2 and 18 minus 6x divided by 6. So actually you are dividing by 12 on both the sides, and remember I have not written equal to 0, but once you divide both sides by 12, it's going to be nothing changing on the right hand side, but on the left you are going to get 9 minus x, and what did I tell you? First part is divided by 2, the second part is divided by 6, so you are going to get 3 minus x. Alright, 3 minus x and 9 minus x, these are the two factors which will be formed. And once you get 9 minus x and 3 minus x, equating it to 0, we are going to give you the critical points. And these are the critical points, and in this case, in this question, they are the probable x, that is the side of the square that is to be cut from the corner of the original square. Now we have to check whether we can take x equals to 9 or x equals to 3, or both are possible. Can you imagine if you take x equals to 9, that is in between, can you form a box? No, it cannot be possible. Just think logically. But still we are going to check it, because we have to explain the examiner why we need to eliminate x equals to 9 as the possibility. We can just take x equals to 3. So when we differentiated, double differentiated, when we differentiated and double differentiated, this is the double differentiation. I am placing x equals to 3 and x equals to 9 one time and other time. When we take x equals to 9, you are going to get certain value which is not going to give you the maximum value, because in order to get the maximum you need a negative number. But 6 minus 9 is negative 3, minus 24 is negative 24. You multiply it, you are going to get a positive value. Once you get the positive value, that just means that you are going to get a minimum value. But we are not interested in the minimum value. We are interested in the maximum value. So we need to check for x equals to 3. If the square side which is being cut from the original square is x equals to 3, we get negative 24, and 6 minus 3 is 3. 3 into 24 is negative 72. When you get the negative 72, it signifies that negative value will give you the maximum value. That is the maximum of whatever content you are actually wanted to see. When this maximum is there, we will eliminate or will ignore that part where we have checked x equals to 9, which was very logical that x equals to 9 cannot be the center point. It cannot be square. You will not get anything if you cut 9 side. Now volume is again x into 18 minus 2x whole square. X equals to 3, replace 18 minus 6 whole square. So it will be 12 square into 3. 144 into 3 is going to give you 432 centimeter cube. Why cube? Because this is the volume, not the area. So this is the whole discussion. Now the basic idea of solving this question is to imagine the original square, then the cutted or eliminated square. So this is the whole expression, and because if you make the expression, if you can actually create or maintain formation of this equation, all other things are just piece of cake for you. If you are on the 12th question, I hope you have already completed 11th question and you are quite known about this. This question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.